This is my third attempt at this first video, so hopefully this one works. All right, so just to review what we did yesterday, I'm going to go back here to page 1. And we did our notice and our wonder in class, so you should have some notices and wonders written down here. We determined that line U was the ladybug and line V was the ant. We also determined that after 1 centimeter, it was 1/3 of a second for the ant, and 1 centimeter took half a second for the ladybug. Okay, when you're dealing with fractions like that, sometimes it's more difficult to conceptualize what that means. So we actually figured out that for number 2, it says, how long does it take the ladybug to travel? 12 centimeters, and how about the ant? So if it takes the ladybug 6 seconds to go 12 centimeters, that means that the ladybug is going 2 centimeters per second. And then we figured out the same thing for the ant. It took 4 seconds for the ant to go 12 centimeters. So that means the ant went 3 centimeters per second. That's going to help us with our information for today. We did our scale on the graph yesterday, and then we marked the points on line U and the point on line V that represents the ant and the ladybug after 1 centimeter. So we're actually going to use this graph to help answer our questions here today. Okay, so the first question says, plot this bug's position on the new bug, okay? So it's on the axes with lines U and V and connect them with a line. So this new bug, we have, it says, imagine there's a bug that is moving twice as fast as the ladybug, okay? So we have to pay attention to this. We have to know how fast the ladybug is going, and we have to figure out how fast is twice as fast. Pretty easy, right? You just multiply by 2. Twice as fast is 2 times. Okay. So let's take a look here at our ladybug. We're going to forget the line here for the ant real quick, and we're going to draw a line for a new bug. Well, let's take a look at some of the easier points to read on this graph. Like if we go 1 centimeter, it's kind of difficult to look at that way. So we're going to just go to where this ladybug meets up on a point perfectly. And it meets up right here at 2, 1 perfectly. So that means after 1 second, the ladybug has gone 2 centimeters. Well, if this new bug goes twice as fast, how far is it going to go after 1 second? Well, if the ladybug goes 2 centimeters, that means this new bug is going to go 4, right? 4 centimeters. So we'll mark the new bug right here. So we're going to stick with the ladybug line, and we're going to go where it meets up perfectly again. It meets up perfectly right here. That means that point on this coordinate plane is easy to read. So this says after 2 seconds, the ladybug goes 4 centimeters. Well, twice as fast as 4 is 8, right? So our new bug is going to go 8. So 2 seconds, and we're going to go to the 8 centimeters. Now, you may already be seeing a pattern here. If you are, continue on with the pattern. If you're not, do it out. It's okay. So let's keep going up the ladybug line here. We've got 3 seconds, lands right here on 6 perfectly. So after 3 seconds, the ladybug has gone 6 centimeters. That means our new bug, after 3 seconds, instead of going 6 centimeters, is going to go 12, right? So let's go over here to 12, draw our line. So it's going to continue with that pattern. Every second, it's going to go 4 centimeters. So 1, 1, 2, 3, 4, 1, 1, 2, 3, 4. Okay? This is our new line for our new bug. I'm going to mark it N. And then the second part of this says connect the dots. Make sure it goes through the origin, right? Because right now it starts 0 centimeters at 0 seconds. Okay, so there is our line for our new bug. So on our paper here, we're going to say C graph because we just drew it here. Okay? All right, so that just froze on me, so hopefully hopefully you got that. If not, I wrote C graph because we just drew our line here, okay? So now what we have to do is we have to write an equation for each of the 3 lines. There's 2 different ways you can write this equation. You can write it in the form of y equals kx, where k is your rate, right? Your rate of, your unit rate, so your constant of proportionality. You may know that from last year. The other way is you could write it y over x equals b over a. This to me is confusing. Everything else we do this year is going to be in this form. So if you're familiar with this, you can do this. It's still the same equation when you do out all the math, because when you do out all the math, you're going to end up with this one anyway. So why don't we just start with this one? So this just means when we plug in an x, sorry you can't see that, huh? So if we plug in an x, multiply it by the rate, right, your unit rate, you're going to get the y. Well, we have x's and y's right here, okay? So for line U, which is our ladybug, right here, here's an easy point right here, 2, 1. So if you plug in, we're going to go y equals something times x, right? Our x here is 2. We want our y to be 1 because we know this point's on the graph. What do we have to multiply 2 by to get 1? How do you multiply by something and get a smaller number? Does anybody remember that from last year? Well, if you want to get a smaller number, basically you have to divide, right? So if I put in a 2 here, what do I have to divide 2 by to get 1? Would have to divide by 2, right? Because 2 divided by 2 is 1. Do you remember from last year that when you multiply by a fraction, that's the same as dividing? So I need to divide by 2 for the ladybug, right? So we say half of x is y. 1/2 times x equals y. So if we plug in the 2, here, half of 2 is 1. That's what we wanted, right? We wanted half of 2 is 1. So then we have our ant, and we want the same form, y equals something times x. Well, let's see where the ant ends up. The ant ends up right here, right? Our point here is 3, 1. If I put 3 in for x, I need to multiply it by something to get 1. 3 times what is 1? 3 divided by what is 1? 3 divided by 3 is 1. So 3 times 1/3, right? Because that really means divided by 3 is 1. Yesterday, we figured out that after 1 second, the ant went 1/3 of a centimeter. Ooh, are we seeing a pattern here? And the ladybug, after 1 second, went 1/2 centimeter. Ding, ding, ding. Now we have a new line for the new bug, and it falls right here, which is really hard to read. This is why I use the points where it lines up perfectly. So here we have 4, 1. So y equals something times x. If I put 4 in for x, what do I have to multiply it by to get 1? Or divide, basically. I would have to do it by 1/4. So 1/4 of 4 is 1. Or 4 divided by 4 is 1. Or 4 times 1/4 is 1. 3 different ways to say the same thing. Does that make sense? I sure hope so. So this is our problem for today, okay? So we just did our graph and we made our equations. So you can check off right here, check off watch the video and do the problem. Then for the rest of today, I want you to do set game and then write down your time. And then 2 things to do today, okay? So I want you to do the practice problems for this section. They're in an app called, or I don't even know if it's an app or a website at this point. It's in Assessments. It's a thing called Assessments. It's posted, the link to it's posted on Google Classroom. And then I want you to do your ticket out the door on Assessments, which is also on Google Classroom. Keep in mind that the ticket out the door, most of the time we do that in class. That's why I call it the ticket out the door. You do it before you leave the door. In Assessments, it's called Cool Down. Okay, just so you know, it's the same thing. Okay, that's it for day 1. And then for day 2, I would like you to do set game as well and write down your time. And then I would like you to start an ongoing Google Doc for math. And it's going to be a vocabulary list for math. So if you ever hear a term while we're doing something in class and you don't know what it means, you have a place to look. Okay? I've written the first 2 words down for you. You just have to rewrite them in the Google Doc. Okay? So it's always in the same place. Then what I want you to do today is day 2, sorry. IXL I4. This is a review skill. So you are capable of getting 100. So you can do it until you get a SMART score of 100 or 30 minutes. If you don't get 100 after 30 minutes, you can stop. If you're practicing something for 30 minutes, that's great. That's helpful. That's awesome. If you get 100 in 2 minutes, you're done. Okay? So I want you to do that today. And then I want you to, not today, day 2, sorry. Then I want you to rate your workload for the week. So circle one of the smiley faces of how you felt about the workload this week. If you have anything specific to tell me, write it in this box. I know it's not written on here, but I would also love for you to tell me in this box something you need more practice with, or something you'd like me to help you with, or something you need more instruction on, so I know which direction to go to. Okay, so rate the workload for the week. Tell me anything specific about the week here, and tell me something you'd need more practice on. Okay? So that's it for day 1, day 2, and then enjoy your time and come back to class ready to learn. I will see you guys very soon. Bye.